the next session is about the concept name is called movements. Concept name is called movements. So in that we have two parts. One is movements about origin. Movements about origin. So this is the first part of the movements concept. So if let us assume g of x equal to x power n, g of x equal to x power n, then the expectation g of g of x, which is nothing but expectation of x power n, is called nth order moment, Why? Because it is called nth order moment, because the power of x is here is n, so it is called the nth order moment, and it is represented by small m subscript small m. So this is what about the moments about the origin. So if you see, so the basic definition is like this. So it is the main concept. So moments. So let us assume function g of x equal to x power n, then the expectation of g of x is equal to expectation of x power n is called the nth order moment, and is represented by m subscript small m. Suppose if you see n equal to 0, then expectation of it becomes x power 0. It is called m naught. That means it is equal to expectation of 1 is equal to 1. So why? Because we already see one of the property, expectation of is constant is always equal to 1. Suppose if n equal to 1, then it is expectation of x. This is called m1 and is equal to x bar. So this is called the first order moment. Similarly, if n equal to 2, it is expectation of x square. So as the order is 2, it is called the m2. It is represented by x square bar. Why? Because it is x square bar in the inside function of expectation. If you have x, it is represented as x bar. Similarly, here we are having x square bar. So x square bar, that's why it is represented as x square bar. So if n equal to n, then it is called the m subscript small n. So if the expectation of x bar is n is called the nth order moment. So in this way we have defined the moments about order. So you can find out any order moment for a given distribution function or for the given random variable. So these are called the moments about order. So coming to the next concept, the second one is moments about mean. About mean. So these are usually represented by mu n. So in this here also, if you assume g of x equal to x minus x bar whole power n, then expectation of x minus x bar whole power n is called the nth order central moment. So here the name is important, central moment. So moments about mean is called central moment. So it is represented by, it is is represented by mu n. Mu substitute small n. So moments about mean is called central moments, that we should remember here, and is represented by mu n like this, and is represented by mu n like this, and it is like this. So in the uh, problem, I mean mathematical manner, so mu n is equal to, mathematically, moments about mean central moments are represented like this: expectation of x minus x bar whole power n, whole power n. These are called the central moments. So similarly, just substitute n equal to 1, 2, 0, 1, 2, 3, and so on. So if you put n equal to 0, n equal to 0. So 0th central moment is equal to expectation of x minus x bar whole power 0 means, whole power 0 means it becomes 1, then it is equal to 1. Then it is equal to 1. So the 0th central moment is always equal to 1. Similarly, take first order central moment mu 1, then it becomes expectation of x minus x minus x bar. So you should remember one thing here. Here x bar means mean value. So the mean value is always a constant value. It is not a random variable. Here the random variable is only x only. X only. That means it is always constant. So if you apply the property of expectation, then it becomes expectation of x minus expectation of x bar. Expectation of x bar. So we already know that expectation of x is always equal to x bar. And we already know that since the expectation, the mean value is constant, so the expectation of constant is always equal to constant. We already know that expectation of a constant a is equal to a. So this we already know. So from that the property of expectation here, the mean value is constant. That's why expectation of x bar is always equal to x bar. That means the first order moment is, first order central moment is always equal to 0. Is always equal to 0. Now moving on to the second order central moment. So how it is represented mu 2. Mu 2. This is one very important moment, second order moment. X minus x bar whole square. X minus x bar whole square. This is called the second order central moment. Second order central moment. It is also represented like this: sigma x square. Sigma x square. That means it is also in the words. It is also called as variance. Variance. So the second order central moment is called what? Here you should remember variance. So whatever in the problem if they want to calculate second order central moment, then what we have to calculate? Variance, sigma x square. Now see what we will do is we will do some operation here. Take expectation of x minus x bar whole square. X minus x bar whole square. Then it becomes, so apply a minus b whole square formula. A square minus 2ab plus b square plus b square. Now take your expectation to the inside, then it becomes what? Expectation of x square minus 2 x bar into expectation of x plus expectation of x bar square. Now why I am taking this 2x bar to the outside? Why? Because 2 is a constant and your mean value x bar is also constant. So whenever expectation moving towards inside, so expectation only apply to a random variable. It does not apply to a constant. It does not apply to a constant. So we already know the property of expectation of ax is always equal to a into expectation of x. In the same way, here in place of a, you are having 2 into x bar. So minus 2x bar into expectation of x plus expectation of x bar square. So here x bar is also constant, x bar square is also constant. So the same way we will write like this. So we already, it is equal to expectation of x square minus 2 x bar into x bar plus x bar square. X bar square, which is equal to expectation of x square minus 2 x bar square plus x bar square. So it becomes expectation of x square minus x bar square. X bar square. So if you write this in terms of mn means moments about the origin, it becomes, we already know that expectation of x square is equal to m2 minus x bar means first order moment that is m1 square, which is nothing but sigma x square. It is also called as mu. So that means the variance of any random variable is represented in terms of moments about the origin. That is, the variance sigma x square is equal to m2 minus m1 square. m2 minus m1 square. This way we have to calculate the second order central moment. So the final one. So you can find out any number of central moments. So up to third order we will do. So the third central moment is mu3, which is equal to expectation of x minus x bar whole. X minus x bar whole. So this is called the third order central moment. So if you expand the using a minus b whole cube, you will get another formula in terms of m's. That means moments about the origins. Moments about the origins. So this is what about the central moments and moments about the origin. Moments about the origin. So the next one is so uh, one point is the third order central moment has another name. It is called skew. It is called skew. So mu3 is also called as skew. So the quotient of skewness. Coefficient of another one is coefficient of skewness. Skewness is equal to mu3 divided by sigma x square. So the quotient of skewness of any random variable is nothing but mu3 by sigma x, where mu3 is the third order central moment and sigma x square is the variance. So sigma, you should take third order of sigma x, then it becomes sigma x cube. So mu3 by sigma x cube is called the quotient of skewness. So these are the formulas we should remember while doing any problem. Any problems. These formulas are enough to do any problem in this unit. So the first one is moments about origin. So these are it is represented by mn. So expectation of x4n is called the nth order moment. So if n equals 0, expectation of 1 is expectation of 1, it becomes equal to 1. If n equal to 1, it is called the first order moment. If n equal to 2, it is called the second order moment. In the same way, we will increase the n value. So similarly, moments about mean value. So these are also called as central moments. Central moments. So the central moment mu n is equal to, it is represented by mu n. It is equal to expectation of x minus x bar whole power n. Why it is called moments about mean? Why? Because here you are taking x minus x bar. So in the same case here, in the numerator, I mean in the previous uh, concept, it is called moments about origin. That means here you take x minus 0 whole power n. That's why that is called moment about origin, and this is called moment about mean. So the name comes like that. So if you apply mu naught, it is equal to 1. Similarly, mu 1 is equal to 0. And mu t is called the variance. Mu t is called the variance, and it is also represented by sigma x square. So we will get after calculation. So mu variance is equal to m2 minus m1 whole square. M2 minus m1 whole square. And finally, third order central moment mu 3 equal to expectation of x minus x bar whole cube. This is also called as the word with skew. Finally, the last one is quotient of skewness, which is equal to mu 3 by sigma x cube. Mu 3 by sigma x cube. So now we will see one problem on this one. One problem on this one. So the problem is like this. The problem is like this. So find mean and variance of very important problem of uniform random variable. Uniform random variable. This is the problem. So to find mean, variance, anything, what you should know is should firstly know the density function of the given random variable. So we know that the density function of uniform random variable is 1 by b minus a. 1 by b minus a. Now I am moving on to the find out the mean of the uniform random variable, that is expectation of x, which is equal to x bar is equal to integral minus infinity to infinity. We already know the formula x into fx of x dx into fx of x dx. Now just substitute the your density function, then then so as the density function is only lies between a to b, so the integral limits are a to b x into 1 by b minus a dx, 1 by b minus a into dx. So as 1 by b minus a is equal to constant, I will take constant outside, 1 by b minus a integral of x dx, x dx a to b, which is equal to 1 by b minus a. So the integral of x is x square by 2, ranges from a to b. I'll apply the integral limits, then it becomes, which is equal to 1 by b minus a into b square minus a square divided by 2. So if you apply a square minus b square formula in the above expression, then it becomes 1 by b minus a into b minus a into b plus a divided by 2. So b minus a get cancelled. The mean value of uniform random variable is equal to a plus b by 2. So x bar, or is also called m1, or it is also called expression of x. Whatever may be the expression, the value is same. So expression of x equal to m1 equal to x bar is equal to a plus b by 2. So now moving on to the next one. So next one, what they ask you is find out the variance. So the variance is represented by sigma x square, and it is equal to, we already know that, m2 minus m1 square. So we know the value of m1, we know the value of m1 here. So we have to find out the value of m2. So what is meant by m2? So m2 is nothing but second order joint, second order central moment. So it is given by integral of minus infinity to infinity x square into fx of x dx. X square into fx of x dx. Now just substitute your density function in this expression, it becomes integral minus infinity. Usually the integral limits are from a to b, x square into 1 by b minus a dx, and take out the 1 by b minus a to the left side, 1 by b minus a. So a to b x square dx, and it becomes by b minus a x square integral is x cubed by 3, ranges from a to b. So after doing this, it becomes 1 by b minus a. Now apply integral limits. So integral limits is b cube minus a cube divided by 3. B cube minus a cube divided by 3. So if you apply a cube minus b cube formula, it becomes 1 by b minus a into b minus a into b square plus ab plus a square divided by 3 b minus a, b minus a get cancelled. It becomes b square plus ab plus a square by 3. This is nothing but our second order moment. So second order moment is calculated nothing but expectation of x square. Now we have m2 and m1. So what we have to calculate is, what we are going to calculate is variance. So variance is equal to sigma x square. That means m2 minus m1 square. Substitute m2 and m1 in this expression. Then we will get m2 means b square plus ab plus a square divided by 3. M1 means b plus a by b plus a by, and it becomes whole square becomes, it is divided by 4. And I will take the cross multiplication here. If you take the cross multiplication, it becomes 4b square plus 4ab plus 4a square minus of 3 times a plus b whole square, then it becomes 3a square minus 3b square minus 6ab divided by 12. Why? Because 4 into 3 is equal to 12. So if you take out all these things, 4 times b square, 3 times b square, then it becomes b square plus a square minus 2ab divided by 12. Why? Because here 4 times ab plus 4 times minus 6 times ab. Then finally it becomes b minus a whole square by 12. Or it can also be written as a minus b whole square by 12. Whatever may be the value. So the sigma x square is nothing but this one, b minus a whole square by 12 or a minus b whole square by. This is the way we have to find out the anything. Whatever may be the random variable, you can find out the mean value and second order moment. From that you can calculate the variance value. Now we will see another problem. The problem is like this. See here. The problem is given some problems, they only gave you fx of x. That means they only gave you the density function. The density function is 3 by 32 into minus x square plus 8x minus 12. Minus 12. So for 2 less than or equal to x less than or equal to 6, 0 otherwise. So this is the density function they gave you. So from this, what they want us is find m0, m1, m2 and mu2. So indirectly they are calling mu2. That means they ask us to calculate variance of the given density function. So finally solution is, so m0 means expectation of x for 0, that means expectation of 1, which is always equal to 1. So the 0th moment about origin is always equal to 1. This we already know. Now second one is m1. So m1 means, I will write directly integral minus infinity x into fx of x dx. So but what we have to find out here is the integral limit. So since they gave you the x is valid only between 2 and 6, the integral limits are here from 2 to 6, x into fx of x dx. Fx of x, what actually they was this x by 2 into minus x square plus 8x minus 12 into dx. This is nothing but the first order moment. Now I will calculate this integral. So take out 3 by 32 common, 3 by 32 common. Then 3 by 32, then it becomes 2 to 6. 2 to 6 x into minus x square plus 8x minus 12 dx minus 12 dx. So now see 3 by 32 integral 2 to 6 minus x cube plus 8x square minus 12x into dx. Then what I will do is I am doing now integral. So the integral of x cube is equal to x power 4 by 4. 8x square is equal to x cube by 3 minus 12x square by 2. That means it becomes 6x square over a period of 2 to 6. Then apply the integral 3 by 32 into minus 6 power 4 by 4 plus 8 into 6 cube by 3 minus 6 into 6 square, then it becomes 6 cube. So this is in case of upper limit. Minus lower limit means minus lower limit minus 2 power 4 by 4 plus 8 into 2 cube by 3 minus 6 into 2 square, that means 24 is the lower limit. So after calculating all these things, what we will get is the mean value of the given random variable is equal to 1 is equal to 4. So the mean value is equal to 4. This is the way you have to calculate the first order movement. The same way, the second order movement, how we calculate is it is represented by m2. And is nothing but integral minus into infinity x into fx of x dx. Sorry, x square into fx of x dx. So what I will write is 3 by 32 integral 2 to 6 x square into minus x square plus 8x minus 12 into dx. Then it becomes 3 by 32 equal 2 to 6 minus x power 4 plus 8x cube minus 12x square into dx. Now I will do integration. So it becomes 3 by 32 into minus x power 5 by 5 plus 8 into x cube by 4, that means 2x power 4 minus 12 into x cube by 3, then it becomes 4x cube, ranges from 2 to 6. So if you apply upper limit, it becomes 3 by 32 into minus 6 power 5 by 5 plus 2 into 6 power 4 minus 4 6 cube minus minus 32 by 5, 2 power 5 is 32 plus 32 minus 2 cube 8, 32. This is the lower limit. So after calculating the above one, we'll get the second order moment is nothing but 16.8. That is, I'll get m2 equal to 16.8. So finally, what they ask you to calculate is sigma x square. It is also called as mu2 is equal to m2 minus m1 square. M2 minus m1 square. We already know that m2 got 16.8 and m1 is equal to 4. That means 4 square. So finally, it becomes 16.8 minus 16. which is equal to 0.8. So the variance of the given random variable with the density function is equal to 0.8. So in this way, we can calculate means variances of any given random variable. Any given random variable. So thank you. I will wind up this session with this problem. So I request all the students to please subscribe, share, like Easy BTech channel. Thank you.